Hi. In this video, we'll take our first steps in iteration. So iteration is the programming construct of doing the same thing or something very similar over and over and over again. And this is often what we talk about when we say what computers are really good at, right? Computers are good at doing really repetitive tasks very, very quickly according to our instructions. So the first and most important type of iteration that we'll discuss today is for loops, and then we'll talk about the closely related construct of list comprehensions, which are ways to achieve outcomes similar to for loops in many cases with much more concise code. So for loops should be familiar to you from your time working with C++. In order to perform a for loop, we need an iterable to loop over. So lists are a common candidate for this. Let's jump straight in with an example. So what I'm going to do is I'm going to sum the integers from 0 to 5. So I'll start with j. So j is going to represent the sum, and I'll initialize it at 0. And then I'll write for I. This in keyword allows me to specify what kind of iterable I'm looping over. So I'll loop over 0, 1, 2, 3, 4, 5. That's a list. I use a colon to state, okay, I'm going to start writing the body of the loop. Then when I go to the next line, notice that Jupyter has automatically indented for me, and this is going to be important in just a little while. I'll say, hey, to j, I'm going to add I. And then let's also print both I and j just to see how we're doing. So when we run this code, we print out a bunch of numbers. So we print out 0, 0 in the first iteration, and then as we go down, we print on the left column the value of j. J goes from 1 through 5. And then I, it starts off at 0, and then it becomes 1, 3, 6, 10, and 15. So we are able to incrementally sum all these integers from 0 to 5 using this for loop syntax. So note a few things. So first of all, this in keyword is very important. It should appear in every for loop. The colon is also required. That separates the declaration of the for loop from the body of the for loop. And then finally, this white space, these tabs here, these are important. If you don't have them, Python will complain. So for example, if I take the same code, I'm going to paste it into the next cell, and I just remove the tabs, now I will get an indentation error. So Python was expecting an indentation after the colon. I didn't give it one, so I got an error. So you do need these indentations in your code in order for you to be able to run these loops. Okay, so the application of looping over integers up to some specified n is extremely common, and in fact, it's so common that Python gives us a dedicated function for doing exactly this. So for example, we can do for I in, and now we use this function. It's the range function. So when I do for I in range 6, I'm going to count from 0 to 5, okay? So for I in range 6, print I print out the integers from 0 to 5. So we can also specify, with range, we can specify a starting value as well as an ending value. So if I do range 2 to 6, I'll print out the numbers from 2 through 5. Okay, so we can iterate over lists and list-like objects like the output of range. We can also iterate over strings. So for example, let's do s equals 2 boldly go. And now for L in s, I will print L. And when I do this, I'll print out the individual letters in this string to boldly go. So when I iterate over a string, I iterate over the letters in that string one at a time. So I can see that I have T, O, space, B, O, L, D, all the way down. Now, another way to achieve a similar result, which is sometimes useful, is to do the following. For I in range len s, so that says, hey, have I go from 0 all the way up to and not including the length of the string s. I can print si. And in this case, I'll get exactly the same result. I starts out at 0th position. It prints the 0th letter. Then it prints the first letter and the second letter, and so on. Another useful thing to do, especially when doing things like text analysis, is to loop over words rather than letters. And for this, we can use string split. So if I do for w in s.split and print w, I can get each of the words one by one to boldly and go. It's sometimes important to keep track of the behavior of the indexing variable. So the indexing variable is the variable like I or L or W in the previous example, which is meant to indicate a typical item in the process of iteration. So one thing that's important to notice is that the indexing variable is actually assigned in the global scope. It's available outside the context of the loop and can later be used. So for example, we used I for counting, L for iterating through letters, and W for iterating through words. And we can see that all of these variables actually have values in the global scope so that we can do things with them later. This can also get us in trouble sometimes. So for example, here's a very easy mistake to make. Suppose I'd like to compute powers of 2. So I'll initialize I equals 1, and then I'll do for I in range 10. And then I'll do I times equals 2. So I'll multiply I times 2, and then take a moment and ask yourself what the value of I is going to be here. So what I would like the value of I to be, I've tried to multiply I times 2 10 times, so I'd like it to be 2 to the 10th, or 1024. So this code is not going to achieve my aim because the value of I gets reset every time the for loop runs, and it gets reassigned in the global scope, and that means that when I check I now, it's going to be 18. So why is it 18? It's because the last time the for loop ran, I had the value of 9. 9 is the final element in range 10. And so in the final iteration of the for loop, it assigned I to the value 9 and then multiplied it by 2, and I got 18. So in order to have a successful code, what I would need to do is to give my accumulator variable that's supposed to represent the power of 2 a different name. And now I can do for I in range 10, j times equals 2. And then when I run this and check on the value of j, I'll get the expected result. So you need to be a little bit careful that you don't reuse the name of your indexing variable in global scope, because this can lead to unpredictable consequences. So just make sure that your variables have nice and descriptive names in your global scope, preferably also in your for loops, and that way they will be less likely to conflict. If you are experiencing errors when you're working with your for loops, then check your indexing variables, because that's a very common source of errors. A common thing that we want to do with for loops is to construct lists of various kinds. So let's consider an example. Suppose I want to make a list of all integer squares up to 100. So let's do it with a for loop. I'll start with an empty list that I'll call squares. And then for I in range 1 through 11, or 1 to 11, so that'll get me all the integers 1 through 10. I'll do squares.append. Remember, I can use append to add items to the end of a list. I squared, and then I can check on the value of squares now, and I'll see that I have all the squares 1, 4, 9, 16 up through 100. Another thing we can do is create a list of the lengths of words in a string. So we have s is to boldly go, and then I can do a very similar kind of initialization where word lengths is an empty list. Then for word in s.split, I'll append word lengths dot append len word to my list, and then I can check on word lengths, and I have the outcome 262, which is what we would expect. So this works well, but you might have noticed that I needed essentially 3 lines here to perform this operation. So I needed 1 line to initialize an empty list, 1 line to start off my for loop, and then 1 line to actually perform operations inside the body of the for loop. We can do this actually much more elegantly using what are called list comprehensions. So list comprehensions are inspired by what's sometimes called set builder notation in mathematics. So a common description of the list of squares from 1 to 100 would be the following notation. Inside curly braces, we say I squared. The vertical line is often read as 4 or such that. I squared such that I is between 1 and 10. So we can use list comprehensions to write very similar Python code using the for keyword in a slightly different context. So let's try this. We'll do squares, and then I'll start off like I'm writing a regular list with square brackets, but then I'll use a variable I squared for I in range 1 through 11. Then if we check on the result of this squares operation, we'll see that we actually got the same list of squares as we got initially, but we only needed one line of code to do it. So fortunately, this is pretty transparent to parse. So my list is going to consist of all values of the form I squared for I running through this range 1 through 11. So I'm going to get all the squares I squared such that I runs from 1 to 10. So list comprehensions give you this nice, compact way to form these occasionally complex lists. Similarly, let's do word lengths. So word length equals len word. Sorry, I need to enclose that in list braces for word in s.split. And now I'll check on word lengths. And I see the same thing. I got 2, 6, and 2 just like I got before. So I've been able to replace this slightly more complicated for loop with a much simpler list comprehension using the for keyword. We can even add conditions in here. So if statements, we'll learn more about if statements in a little while, but in this context, they're pretty easy to understand. So let's do even squares. I only want even squares. So I'll do even squares are a list comprising I squared for I in range, just for kicks, let's go all the way up to 20 this time. So range 1 through 21. But then I'm going to add a conditional statement after I declare this for iteration. So I'm going to add a conditional statement if I remainder 2 is equal to 0. When I do this now, and I check on even squares, I'll see that I now have all the squares from 4 to 400. So that's I ranging from 2 to 20 with only the even values. Another useful trick is that we can iterate over multiple indexing variables. So here's an example. I'll do products, and for my list comprehension, I'll do I times j. So both I and j are going to be indexing variables. For I in the numbers 1, 2, 3, that's one list. And additionally, for j in the numbers 4, 5, 6, that's a second list. And then I can check on products, and I'll see that I have 9 numbers in here. So that's all combinations of product I times j from each of these 2 lists of 3 elements. So I have 3 squared equals 9 items in my list now. You can even get more complicated than this. So one thing that we sometimes want are lists of lists, and we can construct those using this kind of setup as well. So I can do products 2, and products 2 is going to be a list of lists. So I have 2 sets of square brackets here, I times j, and then inside the innermost set of brackets, I'll do I times j for I in 1, 2, 3, and then outside in the outermost pair of brackets, I'll do for j in 4, 5, 6, and then when I check on product 2, I'll have a list of lists. So I have one big outer list, and then each element of that list is itself a list in which I've multiplied a combination of I times j. So in the first list here, I've multiplied the first element of I times, the first element of, I've multiplied the first element of j times all items in I. In the second item in this list, I've multiplied the second element of j times all items in I, and so on and so forth. So keeping track of your indices can be a little bit tricky here, but we can construct very nice complex lists using very simple syntax in this way. So comprehensions are really powerful tools, and when you can write them conveniently in one line, they should usually be preferred to for loops. So use both of these tools for iterating over objects. For loops are usually your go-to for iteration, but you do sometimes want other kinds of iteration tools, and we'll talk about those in a future video.